We're going to do a review of simple compounds. There are 4 basic types of compounds that we will cover in AP Chem. Those compounds will include ionic, molecular, acids, and organic, but we don't have to worry about organic until later in the year. We'll do some simple organic in the beginning, but we'll leave the rest till the end. The easiest way to tell them apart is to look at the first element. If it's a metal, it's ionic. If it's a nonmetal other than hydrogen, it's molecular. If it's hydrogen, it's an acid. So let's start with ions. Ions are formed when atoms gain or lose electrons in chemical reactions. Positive ions are cations, and they're formed by the element losing an electron. Most often these cations are going to be metals, because metals are large and they don't have a strong attraction for their own electrons, so therefore the electrons can be pulled away very easily. So negative ions are anions, and they're formed by gaining electrons. They gain electrons because they tend to be nonmetals. Nonmetals are small, and therefore they have a strong attraction for their own electrons because of the positive charge of the nucleus. But that also gives them a strong attraction for other electrons from other elements. It is possible for them to gain or lose more than one electron. Remember, their goal is to have the outside energy level full, and so they will gain or lose as many electrons as is necessary to fill that outer energy level so that they could have the noble gas configuration. So sodium would lose 1 electron, magnesium would lose 2, aluminum would lose 3. On the anion side, fluorine would gain 1, and oxygen would gain 2, and nitrogen would gain 3, because all of these configurations then will get you to have the same number of electrons as neon at 10. So here's sodium becoming an ion. You see the electron cloud. It got the 11 positive charges from the protons in the nucleus. That's 1 too many. It has 1 more than neon, so 1 electron in that third energy level. So it gives it away. Gets a lot smaller because now it's lost an energy level. Now it only has 10 electrons to go with the 11 protons. And on the other side, chlorine will do the same thing to become a chloride ion, except since it's only 1 away from having the same configuration as argon, it will gain that 1 electron because it's got that very strong positively charged nucleus. The other electrons are all close to it. When it brings that electron in, it makes all the electrons repel a little more, so the chloride ion gets larger. These are some of the common monatomic cations and anions. Basically, you probably want to pause this right now and write these down because you need to memorize these. The transition metals are the D block elements in the periodic table. Remember, that's the 10 columns in the middle, columns 3 through 12. And they are unique because they can have more than 1 possible ion. The Roman numeral is used to designate what charge the ion has. So if we write iron with Roman numeral 2 after it, that means the iron has a +2 charge. So the Roman numeral is the charge. All transition metals have a most common charge and many less common charges. You will be responsible to know what all the common charges are for the row 3 transition metals. The most common ones that we talk about will be iron, which is +3, manganese, which is +2, chromium is +3, nickel is +2, copper is +2. There's also some old naming conventions that were used where they would end the name of the ion with the higher charge, ic. So it would be ferric, would be iron 3, and then anything lower than that would be us, so iron 2 would be called ferrous. These are some of the common transition metal cations, and you can see their charges along with the Roman numerals. But basically, you need to memorize these. Polyatomic ions are formed when atoms come together and bond covalently. So many atoms, usually nonmetals, come together and bond, and therefore they can together gain an electron or lose an electron, and therefore they will carry a charge. Most often they will gain electrons and have extras. Basically, you just have to memorize all the polyatomic ions. Any cations that are polyatomic ions will end in IUM, like ammonium or hydronium. And here are common polyatomic ions. Once again, memorize these. Some helping for the conventions for polyatomic ions, especially the ones that contain oxygen, and so they have the same element basically bonded to different numbers of oxygens. The one that has The most oxygens will be 8 normally. If it has one more than that common one, it's per 8. So this would be perchlorate is the ClO4 with the -1 charge. Chlorate would be the ClO3 with the -1. The chlorite is one less oxygen than the 8, so that's chloride ion. And then hypochlorite would be 2 less oxygens than the 8. So basically, as you add more oxygens, you go from hypoite to 8 to per 8. All right, this will help you know when you have to use 8 when it has 3 oxygens or 8 when it has 4 oxygens. It's called Slivka's square. And if you're inside Slivka's square, the 8 will have 4 oxygens attached to it. So phosphorus is inside the square, so phosphate would be PO4. Arsenate would be ASO4. If you're outside of that, then the 8 will have 3 oxygens. So carbonate has 3 oxygens, nitrate has 3 oxygens. So it's a good way to help you know where the 8 is, so you know when you have one more than that to make the per 8, and if you have less than that to make it ite. This will also help because you have some of these polyatomic ions that have metals involved too, and they are appearing in the D block, like chromate or manganate, and they follow the same kind of thing. You notice the 4A, 5A, and 6A in the nonmetal region. You also notice a 4B, 5B, 6B in the transition metal region. So all the ones inside that box will be O4. So chromate will be CrO4, where manganate, which is outside the box, would be MnO3. So when we have MnO4, we call that permanganate. We need to name ionic compounds. It gets very simple. Just put the names of the 2 ions together. You can do that, you're good. The formulas for the ionic compounds you have to remember is that it's related to the electrons being transferred. So you have a reaction taking place, and the electrons that are leaving the cation have to go to the anion. So you have to ensure that the charges in the compound are balanced. Otherwise, the reaction would never have occurred in the first place. To make this simple, you can cross over the charges. And we call these formula units because you can't differentiate them from a different set of ions. So we just call them formula units. So here's sodium reacting with the chlorine. So the sodium's losing its electron. It's giving it to the chlorine to make it the chloride ion. Then you have the sodium ions. They go together and make that giant crystal, which is our ionic compound, which then we name as sodium chloride, which is our formula unit. Writing formulas, all compounds are electrically neutral. The sum of the positive and negative charges must add up to 0. So there's the crossover. You see you take the +3 from the aluminum charge, and that's going to tell you how many oxygens you need, and the -2 from the oxide charge, and that will tell you how many aluminums you need. And the reason why this works is because 2 aluminum ions will give you a total positive charge of 6, meaning it lost 6 electrons, and 3 oxide ions will give you a total charge of -6, which tells you that it gained 6 electrons. And then when you use the subscripts, that tells you how many of each ion. So your formula for aluminum oxide, which is the name of the 2 ions, is Al2O3. A hydrate is simple. You put a dot at the end of the formula with the number of water molecules. So here's an example of a hydrate. So you would name the ionic compound the way you always would. So that would be copper 2 sulfate, because sulfate has a -2 charge. Copper must be a +2, so it's copper 2 sulfate times 5 waters, which then we use a prefix for 5, which is penta, so we would call this copper 2 sulfate pentahydrate. Acids. Acids can be organic and inorganic. We'll deal with the organic acids when we get to organic later in the year. But one thing that's always true about acids is they always contain a hydrogen that they can give away. That's what makes them an acid. If the anion that's attached to the hydrogen ends in "ide," then they are written as hydro-whatever-ic acid. So it would be hydrochloric, hydrobromic, hydroiodic. If the anion ends in "ate," then the ending is changed to "ic acid." All right, it's missing the hydro now. So if you have sulfate, it becomes sulfuric acid. And if the anion ends in "ite," then the ending is changed to "us acid." So if it's sulfite, then it's going to be sulfurous acid. So as you can see down on the bottom, you have H2S, which is just ide because it's a single sulfur, so it's sulfide, so we're going to call it a hydrosulfuric acid, where if it was SO4, we would call it sulfuric acid, and if it was SO3, then we would call it sulfurous acid. So you should know these and all the other acids. And the only organic acid that we deal with early on is the acetic acid, but we'll deal with more later on in the course. So molecules now are going to be different from ions because they're not trading electrons, now they're sharing, so they can bond in lots of different ways. So prefixes are used to determine how many of each element is involved in the compound, because the same two elements can bond together differently. You can have many different compounds made up of just the same two elements. Ionic compounds, there's only one way to write them. Molecular compounds, you can have a whole bunch. We will only deal with binary molecular compounds now. Organic will be the more complicated ones later on. We always write the less electronegative element first, the one that has the lower attraction for electrons, and the more electronegative element second, and that more electronegative element is given an IDE ending. Never write mono if it's one of the first ion, and two vowels are combined into one if they're put together. So if you end up with pentaoxide, meaning 5 oxygens, you just say pentoxide. So here are the prefixes for molecular compounds: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And so basically you just use that prefix for how many of each element is in the compound. And finally, this is a little flow chart that you can follow to determine whether it's ionic or molecular. The first element is the metal. If it's yes, it's ionic. If it's no, it's molecular. Once you know if it's ionic, your next question is it binary? If the answer is yes, it only contains 2 elements, then it's a simple ionic compound. And if it's not binary, then it's going to be a polyatomic ionic compound. So you have to know the name of the polyatomic ion. Going back to the molecular side, if the first element is a metal, if the answer is no, then it's molecular or an acid, because we don't usually consider hydrogen to be a metal. If the first element is hydrogen, then yes, it's an acid. If it's no, then it's a binary molecular compound.